Hello everyone, and on this video we will be covering solving systems of linear equations by graphing. Okay, so in the last video we knew if we had a point that was a solution to both equations that it was a solution to the system. Okay, so now what we're going to do is we're going to graph both equations and see if we can find out where they cross each other or where they intersect so we can figure out the solution. Okay, so for example, if we wanted to solve this system by graphing, okay, so that means we have to graph x plus 3y equals 10 and x plus y equals 2. Okay, so you know to graph a linear equation, you just pick 2 points and draw a line through it. Okay, so you want to create points for both equations and graph. Alright, so first thing we're going to do is we're going to get our points for negative x plus 3y equals 10. Okay, so we have negative x plus 3y equals 10. And if you have your x and you have your y, okay, and if we have x plus y equals 2, we have our x and we have our y. Okay, now to graph a linear equation, you really only need 2 points. Okay, so as soon as you have your 2 points, you're good. Okay, so now we have to pick an x value or y value and then solve for the other. Okay, so normally what I do is just to keep it simple, I make x equals 0, then we can solve for y. Then I'll make y equals 0, and we can solve for x. Okay, same thing here. I make x equals 0, then we can solve for y. Then I make y equals 0, we can solve for x. Okay, you can pick any value you want. You can make x equal 1, y equals 3, negative 4. I just picked 0 just for simplicity. No other reason than that. You're free to pick any values you want. Okay, so when x is equal to 0, that becomes negative 0 right there, which is 0, so that disappears. So you have 3y equals 10. If we divide both sides by 3, we get y equals 10 over 3, which is also 3 1/3 if you convert it to a mixed number. Okay, so you actually end up with y equals 3 1/3. So we end up with the ordered pair when x equals 0, y is 3 1/3. And here, when y is equal to 0, that means 3 times 0 is 0, so that disappears. So you have negative x equals 10. So if we divide both sides by negative 1, you get x equals negative 10. So you have negative 10, 0 as your ordered pair there. So as long as we have 2 points for this particular linear equation, we're good. That's all we need, 2 points. Okay, and we do the same thing here. We make x equals 0. When x is equal to 0, that becomes 0 plus y equals 2, or just y equals 2. Okay, now when you make y equals 0, that disappears, so you end up with x equals 2. So you have the ordered pair 0, 2, and 2, 0. Okay, so we have 2 points for both of those linear equations. Alright, so we're going to go ahead and graph on the next page because we're kind of running out of room on this one. Okay, so we go ahead and move this over. Okay, so now we just have to, just going back to our previous page, we have to plot those points. So 0 and 3 1/3. So x is 0 and y is 3 1/3. So you have 1, 2, 3 1/3 is about right there. Yeah, it's about 3 1/3. And then you have -10, 0. So x is -10, -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X is -10, 0, which is about right there. Okay, so we have our 3 1/3 and our -10, 0. Okay, so now we just go ahead and connect those two lines. We can use a paper or a ruler, whatever the case may be, whatever you have handy. Just go ahead and draw that straight line there. Alright. Now, this is our equation for -x plus 3y equals 10. Now we get our x plus y equals 2. We have 0, 2, and 2, 0. Okay, so 0, 2, and 2, 0, actually those 2 points right here. So once again, we get our straight edge. And we draw that line through there. Okay, so this, remember that's our graph for x plus y equals 2. Okay, so now we look at where they intersect. So it intersects right here. So it looks like they intersect at -1, 3. Intersect at -1, 3. Oh, let me clean that up a little bit. Okay, so it intersects at -1, 3. So now we're just going to verify that -1, 3 is actually the solution. Okay, so -1, 3 is the solution to the system. Okay, now to do that, we just plug in our -1, 3. Remember that's x equals -1 and y equals 3. Okay, so we have -x plus 3y equals 10. So if x is -1, we have -1 plus 3 times 3 equals 10. Move that up a little bit. -1 is +1. So you have 1 plus 3 times 3 is 9 equals 10. Or just 10 equals 10, which is true. Okay, so if we have our x plus y equals 2, if x is -1, that's -1 plus 3 equals 2. -1 plus 3 is 2. So we have 2 equals 2, which is true. Okay, so we just verified that -1, 3 is a solution. Okay, so that's how you figure it out by graphing. Okay, so let's go ahead and do another example. Okay, so what if we wanted to solve the system by graphing, and we have 2x plus 3y equals -2, and x equals 2. Alright, now the one good thing about this one is, with x equals 2, x equals any constant is just a vertical line. Okay, so that's easy. We don't have to pick two values. We already know x equals 2 is just a vertical line straight up and down. Okay, so we're just going to use that. So really all we have to do is find values for x and y. Okay, so if we have our 2x plus 3y equals -2, and if we go ahead and make our little table here, so we have our x, we have our y, and we just have to pick two values. Clean that up a little. There we go. So again, I'll make x equals 0 and y equals 0 for no other reason than pure convenience. Alright. So now we know that when x is equal to 0, 2 times 0 is 0, so that disappears. So you have 3y equals -2. We divide both sides by 3. We have y equals -2/3. Okay, so that gives us the ordered pair 0 and -2/3. Okay, now with this one, when y is equal to 0, that 3 times 0 disappears. So you have 2x equals -2. So if we divide both sides by 2, we have x equals -1. Okay, so that gives us the ordered pair -1, 0. Alright. So now we are going to go ahead and graph both of those equations. Okay, so if we go ahead and to our next page here, move that up a little bit. Okay, so we know we have 0 and -2/3. Okay, so x is 0, y is -2/3, which is about here. And then we have -1, 0. So when x is -1, y is 0, -1, 0 is about right there. Okay, so if we go ahead and get our straight edge, again using a ruler or whatever the case may be. There we go, and uh-oh, hit my finger by mistake. There we go. Excuse the little bump there from where it hit my finger. But if you're using an online graphing program, it will be a whole lot easier. But this is our graph for 2x plus 3y equals -2. Okay, so now x equals 2 is really easy. It's just a vertical line through 2. Okay, so if we had x equals 3, it would just be a vertical line through 3. X equals 5 would be a vertical line through 5. X equals -1 would be a vertical line through -1, etc., etc., and so on. Okay, so x equals 2 is just a vertical line through 2. So this is the graph x equals 2. Okay, so this should be our solution. And it looks like it's 2, well, it should be 2, -2, but my drawing is a little bit off. Okay, so we want to verify 2, -2 is where they intersect. Verify that 2, -2 is a solution. Okay, so since it intersects at 2, -2, we're going to verify that that's the solution just by plugging it in. Okay, so we have 2x plus 3y equals -2. And remember, this just means that x is equal to 2 and y is equal to -2. Let me draw another line to separate that. Alright, so 2x plus 3y, that gives us 2. Instead of x, we put in 2 plus 3. Instead of y, we put in -2 equals -2. So if we go ahead and simplify those terms, 2 times 2 is 4. 3 times -2 is -6 equals the -2 that's over there. 4 minus 6 is -2, so we end up with -2 equals -2, which is true. Okay, so now with x equals 2, there is no y value to replace. So just replace the x value. So x equals 2, that just gives us 2 equals 2, which is, of course, true. Okay, so we just verified that 2, -2 is the solution. Okay, now the one thing about using graphing to solve systems of linear equations is that it's very unreliable. Okay, but you do have other techniques for solving systems of linear equations that are a whole lot easier, that do not require graphing. But I did want to explain this because this is the general idea behind solving systems of linear equations, and I wanted to make sure you understood the concept before we go right into solving. Okay, so we have the video for solving systems of linear equations without graphing coming up. So hopefully this made sense, and I will see you on the next video.